Welcome back to everyone. Thanks for finding the new link to the meeting. Again, I'm David Elbert from the MaRDA Council and here at Johns Hopkins University, and I'm going to give you the quick disclaimer that the meeting is being recorded. So by participating in the public discussion parts, you agree to having your participation recorded and posted on the web later. If you don't wish to do that, then please only participate through the shared Google Docs, and we're going to give links again to the Google Docs and the like. But then without further ado, I'm going to turn this over to Linda Sapochak, who's going to introduce the day, and Jonathan Schmidt and others who are leading things. So thanks again to Linda and Jonathan and Jane, Taylor, and the rest of the team for organization today. Linda, take it away.
Okay, thank you, David. I'm hoping everyone can hear me fine. And Jonathan, if we could have Jonathan also on the screen. This morning, if those of you that don't know me, my name is Linda Sapochak. A former division director for materials research at the National Science Foundation. I've been retired for the last 2 years, but also was a former co-chair for the subcommittee for MGI. And I'm very happy to be part of the MaRDA Council. Jonathan, would you like to introduce yourself? Who's my co-chair?
Sure. Yeah, so I'll be the co-chair of Linda today. I'm postdoc at ETH Zurich and kind of come from the computational electronic structure and material science side and the connections there kind of to data-driven research from building our own databases. And now we have some European network that we are trying to build also for data-driven research in material science, also with Markus Stricker, who will be joining the panel discussion later. And through this work, I kind of got connected with MaRDA last year. And yeah, I'm happy to help you with the session today.
So we welcome everybody. We're really excited. We had a great day yesterday. So I'm going to share my screen and show today's agenda and give you sort of an overview of today's activities. So let me just fix this. Here it is. So today, yesterday, we talked about the MGI Grand Challenges or challenges quite a bit. And we're going to see that we're going to continue those discussions today. But today, we're hoping will be an actionable day where we actually identify actionables that the community can carry out in order to realize some of the things that we talked about yesterday. So I'm going to skip down to the challenge breakouts because a lot of times people aren't able to stay the whole day. So I'm strongly encouraging you, if you were here yesterday and can't participate later today, the shared Google Docs are there for you to edit any input that you want, any questions you want, the discussion sessions to think about. And so that's really important. MaRDA is all about the community and we need your input. So I just want to jump down to the breakout sessions first because some of it is a carryover from yesterday. So David Elbert, as you see down here, in the third session, finding new challenges, how to create stakeholder input to create new challenges. That is a continuation from yesterday, and David has put a lot of great questions and things into the Google Doc for you to think about. So the second one is the MGI Challenges Vision for the Future. And this is a special session for the student and postdocs that I will be leading. So I strongly encourage the students to come and we want to hear from you and to help you encourage you to be a stronger part of MaRDA. And the third one is the first breakout session is developing guidelines to streamline data deposition for advancing materials research. And this is something I want to talk about in more detail because this is going to be the subject of our panel discussion this morning. And so MaRDA is really great about working with the community and addressing many of the challenges that need to be overcome for all of us to realize the vision of MGI. So one of those working groups, and I'm going to stop share for a minute, I'm going to share some slides. One of those working groups I've been involved in, and I'm going to put this up here. I'm hoping everybody can see that, and I'm going to play this. So one of the challenges that the MaRDA Council talked about was the challenge for different communities to publish their data. And I think yesterday when Tyrell brought up something really important when he talked about the exponential growth of the publication of material science papers, and a lot of them are based computational and data driven, and a lot less in the synthetic and experimental arena. And that just goes to show that there's a big challenge and different challenge for the different parts of the materials community to publish their data in order to realize the value of MGI. And so one of the things we did, along with my colleagues from the MaRDA Council, Jane Greenberg from Drexel, Taylor Sparks from University of Utah, and of course, David, we formed a meeting with some of the community to talk about some of the challenges in publishing. And who participated in that? There's a list of some of the people, editors, people from different journals. But what we did was we asked them 3 questions. Does your journal have a fair data policy? Is the policy included in your guide to authors? And what are some of the challenges your journals encounter in managing materials data, both from the perspective of the operations and contributions to authors? And we found there were many, many challenges. And we felt it was really imperative to discuss that with the broader community. And so today, in the first part of our session, we are going to have a panel discussion that talks a little bit about the outcome of that discussion and to bring the discussion to the broader community. So Jonathan, do you want to add anything before we turn it over to the moderator for the panel?
Yeah, maybe, or I think you mentioned before to me also that for the MGI challenges on the MaRDA website, there should also be some links where one can become active in some planning groups for the respective MGI challenges. So,
oh, that's right, Jonathan.
Everybody is also welcome to contribute there and connect.
We want to reiterate what David brought up yesterday. If you go to the MaRDA website and at the top of the page in the banner, there's MGI challenges. You can join any of those challenges in a planning group. So think about that, and we strongly encourage you to do that. So we'd like to introduce the moderator for the panel of the day. Jonathan, would you like to do that?
Sure. Yeah, so it will be Jane Greenberg, professor in the College of Computing and Informatics at Drexel University. Also, contributing very actively to the research here on metadata standards and so on in material science. And so, yeah, please take over.
All righty, I'll take over now. I'll moderate. Thanks so much, and thanks for the setup. Yeah, and I'm also really excited. I'm joined the council this year, or I guess starting last year, and it's just been great working. In our panel today, I'm going to just give brief introductions first for the other panel members. You can read about them, and to each of the panel members, if there's something I didn't say about you that you want to share, please add it when I target you with your question. The format is I'm going to start with some targeted questions given the expertise that each of our panel members bring to the table. After each panel member answers the targeted question, we will give a little bit of open it up to see if another panel member too wants to comment. We want to make sure we get through each of the panel members given our focus on you and your expertise. And then we have some general questions that we'll open it up also to audience members and so forth. We have, as Linda announced, the breakout groups later on where we will also be able to continue the discussion. So in terms of our panel members, when I say your name, just give a wave. Actually, I can't see. Is Kamal here?
Yes, I'm here.
Okay,
So
good. Sorry, I couldn't.
KNC6, I'm trying to change my name.
Okay, sorry, I couldn't see. So Kamal is here, one of our panel members. Kamal is a researcher focused on atomistic material design using classical quantum and machine learning methods. I think you're famous for developing Jarvis. And we'll move on. Next is Taylor Sparks. Taylor is also part of our working group. Taylor is a professor in materials science and engineering focused on combining interest in materials informatics and sustainable engineering. You're also the chief editor of Integrating Materials and Manufacturing Innovation. Dan Palmer is a graduate student, you're a doctoral student, I believe, Dan.
Yeah, PhD.
Yes, at the University of Illinois, Urbana-Champaign, at the Materials Research Science and Engineering Center. And Dan, when you have a chance also, when I target you, please tell us a little bit more. He has a really interesting, excellent background in developing tools and infrastructure and dealing with data sharing. Markus was already mentioned by Jonathan. Markus is a professor of materials informatics and data science and a member of an interdisciplinary center for advanced materials stimulation at Ruhr University in Bochum, and active in the FAIR world, curation, management of heterogeneous, multidimensional research data. And then Jonathan was already introduced before, and just to reiterate, he's a postdoctoral research in materials theory, the materials theory department, focused on computational materials and a major contributor to community standards on data workflows and codes and material design, and is really active in this area. So we're delighted to have all of you, and I have already been introduced again, so Professor. So I'm going to start and just dive in with the targeted questions if folks are okay. We have time for discussion. So Taylor, I'm calling on you first. And just for the benefit of the audience, an issue that came up during our session, the session we had with the editors this summer, was that it is difficult to find data. If published papers, in published papers, because of the inconsistent data citation for articles, does your journal, the one that you're the chief editor, have guidance on this? And do you think this is something that can be made more uniform?
Yeah, great question. I will say that I've spent the last 5 years in editorial capacities at 3 different journals. One of those was Data in Brief. It is a data journal. They had very specific rules about how they wanted the data to be findable by people, right? You had to describe what's the value of the data, how should people interpret it, what were limitations of it. Like, it had a pretty good format. And because it was a data article, there's no, hypothesis and data and conclusions. It's just describing the data. So they were sort of on the far end of doing it the right way. I also served for 4 years as an associate editor at Computational Material Science, where a lot of the papers that I got, at least got plumbed to me, were ML papers where they were using data for sure, but very rarely was that actually showing up in the papers themselves. So something I really pushed for when I was there was, technically, if you looked on the guide to authors, it had a fair data, statement said, we believe in, the data has to be all these things, findable, accessible, interoperable, reusable. But in practice, it wasn't being enforced either by the reviewers or by the editorial team. So something I really was pushing on there was putting teeth into that. So before I'd send it out to review, I'd say, boy, this looks like an interesting paper. I want to see the data though. Like, you need a data availability section so it can easily be found. That journal was nice because it called for a data availability section. So you knew right where it was every time, typically right above the acknowledgements. And now I'm at, just for the last month or 2 months at Integrating Materials and Manufacturing Innovation, where the call says that we believe in fair data, that it should be available, but we haven't provided that level of detail yet in the guide to authors, something I'm hopefully working on. IMMI also publishes what are called data descriptor articles, right? Which is sort of like the Data in Brief articles. They're just articles on the data. So those ones do a good job, but your approaches that use data in some way are not always being published. And I think that's pretty representative of what we saw when we talked to these other editors, is a lot of times the general feedback we got from them is like, boy, I think our journal, Guide to Authors has a statement about fair data, but when you ask, like, do you check for this? Do your reviewers check for this? Does the processing staff check for this? The answer is typically no. And so I'm glad to hear that the large publishing houses have made moves towards saying, hey, we care about this. I think the next step that we as a community have to do is, how do we show that we care about this by incorporating it in part of our processes? And maybe that's in the publication processes, or maybe it's even earlier. And then there's an open question about, should journals even be the place where data gets published? Are they the right format for publishing data? Which I guess we could sort of talk about.
Yeah, it's a little like the Wild West in some ways, in terms of there's stuff happening, but standardization. Yeah, thank you. I just to open it up, I saw maybe a twinkle in Jonathan's eyes, and I don't know, Camille, if you wanted to talk about something with, I'm calling you out, even ethics, just we have, you know, ethics in citing using data response. I mean, just a comment or two from the other panel members. And also, just a reminder to people, we have before you guys talk, there's a link to the session in to all participants in the chat, and we'll gather questions there as well. So just brief comments from the other panel members before we move on. Panel members?
Just a comment on the data availability section. So similar to computational material science and IMMI, I'm an associate editor of NPJ Computational Materials, and all the editors recently wrote this article called Setting the Standards of Materials Data, and they made this kind of repository. I put it here. So in that, the worst thing in the data availability section is data available on request. That's the worst thing ever in the materials community. So we try to avoid that kind of statements. So in terms of journals enforcing or suggesting this kind of guideline, that's one thing. And in terms of ethics, the question you raised, usually I would like to point out, just because it's online, that doesn't mean it's free, right? You know, that's something is students, especially the beginner students, they think this is just, if you say sun rises in the east, that is kind of the statement that you can use it in your article. But if it's a number or a method that you are citing from some literature, then you should cite that. So you should distinguish between universal truth and scientific kind of findings. So I think it's very important to have some sort of ethical training, or maybe give some credit for this, right? Especially for the beginner master's students or PhD students, just maybe, I don't know, 1 credit course or something, or I don't know, something like this, where students can think about, or professors can think about how to get this before we get into research, like, you know, how to give appropriate credits. And in this way, when they cite some paper, they also get, you know, cited in this, and easy to find out their research article. So a couple of those 2 thoughts.
Thank you. Actually, Jonathan, just be very brief, because I want to make sure we get through all the targeted questions and open it up to the audience. So just a brief statement.
Sure. I mean, I will then during my targeted question, I guess, comment on this. Again, as well, concerning the research data availability statements. We know now, I mean, that, let's say, majority of the journals, I mean, material science, encourage at least having one of them, and certain percentage requires them, which is smaller. But then only very few of the journals actually do not allow you to put the data available upon request, which, I mean, then there could, I mean, basically also be no, I mean, it's close to having no data availability statement in the end. So that's definitely something where we can improve, and then I will maybe say more later. Okay, thanks.
Yeah, thank you. And actually, you know, we can discuss this more even in the breakout groups this afternoon. So actually, Kamal, I'm going to go back to you with the next targeted question, which is, one of the frustrations expressed by the community is that it's very time consuming to figure out how to organize data and provide the necessary metadata to meet the you know, making it interoperable in the FAIR standards. And how can the NIST repository aid researchers to, you know, take on this challenge? You want to comment on that?
Yeah, it's not just NIST. I think most of the data providers, right? For example, especially for atomistic data, came together and developed a consortium or platform called Optimate, for example. And the Optimate framework kind of tried to combine or give a schema for at least atomic structure data, right? And they could combine, I think, more than 20 or something databases like this. Once it is available, now external partners can, you know, use that API and do a lot of post-processing with this. Now, I want to point out, this is just for atomic structure. In one of the meetings, I talked about how about images like STEM or TEM images, how about spectra like XPS, and they're scratching their head like, I'm just spending so much time just on the atomic structure data. So there is a lot of barriers, and consortium like Optimate is an amazing example how communities should come together to solve this problem. And in terms of metadata, I would like to cite one of the work called Jarvis Leaderboard we started. And this is a community effort where almost all the national lab in the United States and major universities kind of try to assemble metadata, which is not too overwhelming, but also not too less, right? So what should be the just bare minimum metadata that is
The
necessary
sweet
for
spot.
sweet
The
spot.
sweet
Yeah,
spot. Yeah.
we spend a lot of time and
Yeah.
effort to come with a sweet spot. Of course, it may not be perfect again, but that's where we started. So in terms of our effort, these are the two things we tried. And again, I don't want to take too much time, but I can discuss later if you need more details.
Thank you. It's very, very helpful. Just panel members, anybody itching for a comment or annotation? All right, we're going to keep moving because I am seeing there's a lot of good questions coming in that will help us continue on. So I'm going to turn it now to Dan. And Dan, after, please also tell us a little bit about your background. So, but would you please comment on how and when you learned about data sharing, the concept of fair data in your experience, as well as what you think the situation is with your cohort, other grad students or researchers? This kind of relates back to the initial, points being made about, could there be a required course? I think that was you, Kamal, who kind of said that, like a 1 credit. So hearing it from somebody on the ground right now. And how did you learn about materials repositories you use or other, the whole shebang? Go for it.
Yeah, so I was an intern actually at Argonne National Lab during my undergrad in the Center for Nanoscale Materials, and sort of how I found out about fair data principles was my main task at the CNM was to create pipelines that would organize your data and at least clean it. So basically take like an unstructured, folder of DFT calculations, annotate that using a like user-defined metadata scheme, and then clean that data, make sure you don't have any like bad DFT calculations in there, and then go from that and publish that on the materials data facility. So a lot of what I did was making life easier for researchers to publish data and know that it was like actually clean data and that it was reasonably and should be published data. So that's how I found out about the fair data principles. And so basically everything I did was to ensure that it was like the easiest path for researchers to just publish fair data research. And so a lot of what I did was I worked through the MDF. And so that's sort of what I have my main experience in. And actually, when I've been here at Illinois, I've been leading like seminars on how to use the MDF for other researchers. So the MDF is really nice is that because you can publish both experimental and computational data. So I've been leading sorts of seminars to let all these other different researchers know about how to use the MDF and how easy it is. So that's sort of my experience with the data repositories here. And I have other experience with other data repositories, but nothing like the materials data facility. So
It's really excellent. It's like training the trainer, or,
yeah,
on the ground boot camp required.
Mhm.
I guess Olga talked yesterday a little bit about the fair train. And, there's opportunities out there, and I think this is something to discuss. Any of the panel members want to make a comment on this point? Training or their doctoral students or anything? We'll keep moving.
Short comment.
Yeah, sure.
This training aspect is, I think, one of the critical points in all of this, because if people don't know how to do it, then who would do it? And the discrepancy I saw or still see with all of these efforts of forcing people to publish their data is that on the one hand, for example, in Germany, the DFG, the National Funding Agency, requires that you keep your data in a format for 10 years after publication, so that just in case you can go back to it and if there is any dispute about that. But rarely have I seen in practice that this is other than a dump of the file structure of some postdoc or a PhD student. And of course, it rarely goes back, but there were occasions where people had to spend days to find the data again. And so this reality versus expectation is kind of a training problem. I guess also a time problem. We touched upon that point. It takes time to sort your data. And then what is the sort of the most confusing thing for me right now is we have these national initiatives that try to harmonize data formats and data standards across different subdisciplines. And then this would just be an harmonization effort in general if all was there organized already, and then you just translate it into a different format. But that's actually not the case. So you start from scratch again with the data.
Yeah, you're bringing up really important points. Like what's the, low-hanging fruit? What's the most important pain point right now in this whole ecosystem? Something to think about. So Markus, since we have you, I'm going to continue on with a targeted question for you, which is computational materials science increasingly benefits from data management, automation, and algorithm-based decision making, and we can even add an AI there. So what are the challenges for experimental materials science to catch up?
Yes, part of my research is related to this collaborative research center that was mentioned in the introduction, and this is a group of 18 PIs. Only a few of them are doing purely simulation and theoretical work, and the rest are various different characterization techniques for surfaces and electrochemical processes. And to make this a little bit short, one example in my capacity as part of the team that manages this research data is that we have three groups that nominally do the same experiment. They do a scanning electrochemical cell microscopy, so on nominally a high throughput method, so you can get a lot of data quickly, comparably. I mean, it's still orders of magnitude slower than high throughput DFT calculations. But even those three, even though they are situated all at the Ruhr University Bochum, and they're all using the same kind of machines, send us different data formats. And so even in this very small section, you have such an overhead in organizing this in a way that at the receiving end, which is also a project of me, where you want to make use of the data, you have conversations and conversations and conversations about understanding what they actually do and what are the metadata and how do they record it, or can we make their life easier by letting them dump a zip file in a specific format so these measurements are organized in a different way, because then you have to connect it back to the other measurements, for example, chemical characterization of the surface, say the composition or something like that. Because if we don't manage to connect all these data points across the characterization chain, then this doesn't work. But now I have to circle back to the actual question. The benefits from automation are mainly because computers do the work for you. And one thing that will not go away, in my view, at least for most of the experimental procedures, are that often you require some kind of manual interference to tweak a setting or push the small needle somewhere, or so there is this inherent quality of human interaction in there to tweak the settings towards a best result, whatever that is. And the solution to this, to incorporate this data, is of course the person who does this needs to somehow record this. So you will not really ever go to automation and having this high throughput in that sense, but you can at least make sure that the data you create can be connected to other data, so you have a multi-dimensional characterization at the ready, even if it's fewer data points, because then they are really valuable. And it connects to this training aspect. We have an integrated, we call this a research training group for the PhD students, where they have lectures about or workshops about how to do this for their specific case.
Yeah, I almost want to say, are you talking even about metadata or like provenance metadata about the human intervention of this that also needs to be tracked?
I mean, it could be as simple as, sorry to interrupt you. Some of these electrochemists say, before we do this very high resolution surface characterization, we need to clean the sample. And when they clean the sample, they characterize it again to check if there is any oxygen in there. So if there is oxygen in there, where does it come from? If the transport was in air, that could be one culprit, but it could also be that the sputter chamber had a leak, so you didn't have low enough pressure, high enough vacuum, or wherever you want to see that. And so we have so many ideas how you could automatically track this kind of wrongness in data, but as soon as a human touches a sample, or the box of it, not the sample itself, they have to
Yeah.
record, I'm pulling this out of the machine and it's exposed to air, maybe humidity at 60% or 80% is, maybe that does make a difference, and so on. So this is very, very hard to capture, or
Yeah.
very hard to document. It's not
Yeah.
hard to capture, it's hard to make people document it.
Yeah. Yeah. Human nature is at play as well. So excellent stuff to talk about. We're doing great on timing, and I think we're going to be able to get to the audience, but we want to go to Jonathan here. And Jonathan, as part of Cost Action, you are leading a project researching the state of journal research, data policies, and material science. Why are these policies important, and what is the current state? And jump on in.
Yeah, thank you. Yeah, I mean, Taylor already touched upon this, and I mean, basically, I mean, whenever I mean, we want to publish some article, then we usually sign some editorial policies that we will follow them, and part of these are usually some research data policies. And so we know from other fields where this has already been researched a little bit more, like biological sciences, that in the end, if, for example, funding agencies change their research data policies, like, I mean, in Europe and Germany, they have become quite a bit stricter in recent years, then this changes how the researchers talk about it. So we'll have these meetings like here, we'll have NFDIs in Germany, and people will change about how they talk about the research data. But then if we actually want to see changes in the publishing behavior, then changes in research data policies of the journals are much more influential, because in the end, the journals are, of course, the final arbiters who decide what articles will be published, and I mean, what's the reputation of the journal where it will be published, and so on. So in the end, for the career, I mean, this is very essential. And so if we can achieve changes in the research data policies of these journals, then they can really transfer and change the whole landscape. And now we, in the Cost Action, together with Markus and then a lot of other people in the Cost Action, are looking at kind of recording the state on the material science community right now, looking at a few hundred journals and encoding these research data policies. And let's say the preliminary findings are mostly that there's some progress and a lot of things are encouraged right now. So most or nearly all journals have research data policies, and most of them encourage research data availability statements, but very few enforce anything. I mean, there are some examples like digital discovery or scientific data, for example, who really enforce certain standards for certain data types. But in general, it's mostly encouragement, and nothing is enforced. And so other communities like bioinformatics, for example, already have common standards like the Genome Standards Consortium, that is developing some standards for bioinformatics data. And so there the community already kind of got together and was able to agree on some standards. And now there are more and more journals who require researchers to follow these standards. And then, I mean, we are much closer, I mean, to really useful, fair data. And so it's one of the questions, or for me, how we in the material science community can also arrive at these standards. So Kamal already mentioned Optimate API standards, which is extremely useful. And so we also, at some point with the last year, published the Alexandria database, a large crystal structure database, and there, and we're actually just able to take this API standard and immediately make it, I mean, accessible through the same standard as the materials project and Java's data, Airflow data, etc. And so if we can achieve that for other data types in the material science community, then, I mean, this would be extremely useful. But of course, this then requires, I mean, ontologies and metadata standards that the whole community can, or sub-communities can agree on, and then these can be enforced also at the journal level. And yeah, actually, I think MaRDA can have a real impact here, because during our research, looking at the research data policies of Springer Nature, we found one funny sentence, and that was that Springer Nature says that we should already follow, encourage researchers to follow the standards of the Materials Research Data Alliance and the Materials Genome Initiative. But then to my knowledge, these standards don't officially exist yet, but of course we can create them here. And as soon as they are created, then Springer Nature already encourages everybody to follow these standards.
The perfect segue. It's kind of like, starting with Taylor and ending with you, at least for the targeted questions. You guys have made us a nice package. I think, you're emphasizing, the journals are stakeholders. I just take a second here before we open it up. I didn't share about myself, but I would like to, which is, because you mentioned the biology community. And one of the things I have tossed out is the biology, community got together and a lot of journals joined a joint data sharing policy. And that's part of how the Dryad data repository kicked off, and journals signed it. And it was part of the publication process of many different journals. And so maybe there's room for something like that in materials science, where stakeholders come together and really do sign and advocate for a joint policy. But as you're saying, we need the standards too. So moving on then, I think I'd like to open it up to the questions in the Google Doc and see, because we have some really good targeted questions and follow up. So I'm going to just move down that, unless there are any other comments from the panel members at this point. All right, so we'll start with John Allison has a question about data citation, and saying, beyond making data available, it's important to cite data that's made available. And that's an incentive for making the data available. Oh, wait, let's see, that somebody just changed. Somebody just deleted the question? No. Okay, the community knows how to cite papers, but citing data is very rare. Does MaRDA have a role? So this follows up. So MaRDA has been identified as having a role, according to Springer Nature, and this is part of the reason we are having this. We think that we are in a position to have a role, and having all the stakeholders involved is what we've been working on and hearing from people. So yeah, and I have here another answer David just put in. MaRDA has been involved in discussions with the Make Data Count, the event that Linda discussed that we had. So MaRDA can have, I think, more impactful role in helping this. So thank you. Do any of the other panel members want to comment on that? Or I'm going to move on to the next question. Go ahead, Markus.
Yeah, just shortly. I'm not sure if I'm hitting the question right with my answer, but it seems like it's about how to cite data, and there is actually I put it in the chat, data cite. There is already a suggestion how one should cite data or could cite data. They exist for quite a while
data
now
cite
with mandatory and optional metadata along with it.
Yeah, thank you. Yes, data cite is a big one, and yeah, MaRDA is also works with data cite. So it's according to, yeah, and it involves giving a data set a DOI. And there's been some really excellent work coming out recently about persistent identifiers. We all know, I think, that there's no shortage of persistent identifier systems, and some are maybe more robust than others. So this is also endorsing and finding a data citation standard that works with a strong persistent identifier. So I'm going to move on to the next one, which is how can we build a framework to capture experiments, procedures, results, analyses, contextual data, the whole enchilada in ways that experimental campaigns are truly reproducible. The word accountability comes to mind. This is from Benji. And I think, what Benji is asking about is, the pipeline, capturing the whole pipeline of the experiment and making it reproducible. So building a framework. It's a biggie. It's more of a discussion, but question than a question, but it's all good. Let's open it up. Go ahead, Markus. You look ready.
Yeah, we have exactly this problem in this center, and what we resort to currently is we have our own research data management system, which is a database of specified and unspecified objects. And one of these objects is, for example, a hypothesis. So you could go into the database and add an object that is an hypothesis that is maybe based on a conversation you had with someone. So I hypothesize that this and this element would have a beneficial effect in this context. And so from this, you can then trigger a synthesis request. And the synthesis request is then sent to the project that synthesizes the samples, and this is then sent to the other characterization teams. And so you have, at least in theory, a full provenance of who had the idea, who participated in the characterization and in the discussion, and who produced the results. And then in the end, at least that's our vision, that you can make a database query for a specific object, pull out the graph of this, and make this directly a data set that you could then upload with a specific, with a persistent identifier to say something like Zenodo or whatever that has this. And then you, in the paper itself, you cite exactly this, because then it's there. But these are so far in the process of implementation. And so in a sense, that's, I mean, there's this saying, herding cats, and I already said that even the nominally same experiments give you different data and metadata. And so this harmonization, that it fits in our research data management system, or the other way around, that our research data management system fits to the needs or the input data that comes, is a work in progress that takes quite some time. And I believe this will be very hard to implement at a, say, national or international level, across different measurement categories. It could be the case that you agree on, I don't know, a certain standard for TEM, but even TEM has so many sub categories. But if you have a research project like this, you could implement something like this with the people you work with in direct interaction. And that's at least right now crucial to achieving something, this direct interaction with people, other than setting standards somewhere. So pragmatic approach.
Yeah, pragmatic. Would you say we're in beta stage?
Well, alpha plus maybe.
Alpha plus. I was at a conference at DOE on some of this stuff, and somebody said we're in the Stone Age. I like to think we're in the Bronze Age. We're getting further. David is putting a lot of good notes in there on the PID stuff too, and I just want to encourage people to look at the shared document, the FAIR RCN. But thank you for those comments on this discussion point. Any of the other panel members, Kamal, do you look like you want to say something too? Go for it.
I do want to comment on Benji's question, especially about reproducible experiments. So NIST has something called standard reference materials. I'm pretty sure some of you or most of you are familiar with. So this NIST standard reference material, probably I'll put the link here. Can anybody guess how many are there? Just without taking a look at the link. How many materials are standard reference materials? So you'll be surprised, it's only like 50s or 100s. And just to maintain that standard, there's a dedicated building and number of staff. That's their entire job, to maintain that standard. So can we, at a different country level or at MaRDA level, can we have a consortium and dedicated staff that maintain that standard? Unless we do that, in my opinion, there is very less chance, and we're going to stay all the way to the Stone Age of high throughput experimentation. That's just my take.
I've got a quick comment on this thread. I loved hearing what the tool that Markus, I don't know if you guys are building that, I didn't quite catch that if you're just using it, but that essentially sounds like a good electronic lab notebook system where you can track this provenance and things like that. My only comment on this is that, having been somebody who's grappled a lot with how do we capture this stuff, and I was fully, using like the GEMD that Citrine put forward, and I've now changed my mind on that. And I think that we now have this sort of universal translator tools in language models to take just descriptions of what we did and put them into whatever format we're interested in. You can get as granular as you want from the text that's provided. And this seems to align with what researchers want. They just want to describe what they did using words, right? They don't want to type up the experiment. That's what they do in their lab notebook. So as long as it's digitized, I would say that we now, and I've been surprised to see over the course of my career, the change happen here, how good these language models are at taking that unstructured information and structuring it into whatever format you're looking for, which, having been also a user of ELNs and finding them cumbersome because it doesn't have a category for the new unique thing that you did, or just the latency and issues of using those is annoying. it maybe bypasses that.
Taylor, I don't know if you're following the Google Doc, but this is so funny that you brought this up because Scott just put a comment in there on this discussion point. Could some of this be assisted with greater usage of ELNs at the individual level, the laboratory level, or LIMS? And I see Jonathan's hand comes up, but you know, there's a lot of mixed feedback on LIMS, but they're here, you know. So I don't know. Jonathan wanted to jump in, so we'll let him, but Taylor, also, if you have a comment on LIMS further, just given the question, we'll go back to you. Go ahead, Jonathan.
Okay, yeah. Yeah, I mean, I guess just the problem again that, I mean, just as for other machine learning models in material science and anywhere, I mean, before we can even say, I mean, if they're good, we need data to prove, I mean, we need benchmark data to prove, I mean, kind of how they perform. And this is the challenge, I mean, that in order to do that for LLMs, to extract, for example, experimental data from papers, we need some structured data format and that one can agree on for a certain experiment, to then be able to create some benchmark data. And then, of course, only, I mean, we can say then that the LLM is actually good at it, or it's not, and we have to improve it. And then once we have achieved that, then we can effectively use it in practice. But so that's kind of the challenge they see right now. And so I don't think there's some way around having some form of, I mean, structured data to really describe the experiment, because we need to know, I mean, that it performs well in order to use it in practice.
Yeah, good point. And I mean, there's a variety of ELMs, and then there's a lot of in-house systems. So I think this is a further discussion, but I'd like to move on. I mean, I think we could probably have a whole panel on this topic. I'm going to move on to a new question, which is by Glenn Tarsia. I hope I'm pronouncing it right, Glenn. And it's about licenses. For materials common, we've been looking into licenses. What are your recommendations around licensing of data sets? Is there a set of licenses that you recommend? You know, what does it mean if there isn't a license? I mean, there's things like, you know, CC, Creative Commons, CC 0, CC BY, you know, which are open. You know, David has a comment in here saying that it's a great question, and some things about some other, yeah, David, you also comment on Creative Commons, no commercial derivatives. So just opening it up about some comments on the licensing, and you know, this does go into some of, you know, the reproducibility and question as well. Thoughts on that from any of the panel members?
From a legal point of view, I think it's a very quick answer. You're the author. You can decide what kind of license you put in there. But from the point of a user of the data, is of course, if it's less permissive, better. Oh, wait. Now I think twisting. The more that is allowed, the better. So CC0 is of course. You don't even have to attribute it. That's probably the least interest of the person creating the data. But anything that has CC BY, so author attribution, is I think a very good way for the data to be actually reused and properly cited. Yeah.
So Glenn, we can make sure there's a link put in there. I'm aware of some work where there's like a directory, at least, of some. I can't multitask. I can't type two things at once, but there are people that have listed directories of licensing for data and looking at the Creative Commons. So there are licenses out there. Let's see. I'm going to move on to a question by Scott. How do we ensure the continuity of data if links in the articles become obsolete or dereferenceable? Thoughts? Oh, Jonathan, thank you. Like now I'm thinking when I do these questions, like everyone's still muted. I'm like, please, somebody.
Yep.
Thank you, Jonathan.
No, so
there's a
that's
lot of good
definitely a
questions
challenge.
here.
I mean, with the public, I mean, fair repositories like, I mean, Nomad, Materials Cloud, Synodo, I mean, and Red, I mean, there is some progress in this direction that, I mean, some of them, I mean, at least guarantee that the link will stay active for a certain amount of years. But of course, this is still limited. And right now, I mean, we can really, with the machine learning, we can really benefit from experimental data that's much, much older than 10 years. And so the financing for that, and especially for larger data sets, is usually these public repositories, I mean, are limited in terms of the size of data that you can upload without paying. And this is definitely an unsolved question. So the money, yeah, is a big barrier here, I would say, in the long term.
Yeah.
I can maybe
Excellent.
add experience from our university. They just 2 years ago they committed to a research data management system with persistent identifiers, with a commitment to the future to keep this online and hosted. So at least on a university level, and I see this on multiple universities in Germany, the institutions are committing to open data, or at least the infrastructure for open data.
Yeah, thank you. Markus, you have your hand up. Was that just because of that? Okay. There are other excellent questions in here, but I want to get back. We had some additional questions for the panel members that you folks may have already looked at that were put together. I just want to open it up. I don't think we're going to get through. I'm just being mindful of time. I want to get back to the questions that we had, sort of general questions about activation barriers and awareness, and some of it was touched on by the audience, but I do want to make sure we ask these other questions that were put together, and then we can go back and it looks like even the questions that are being asked, other people are jumping in with some good suggestions and answers, and we can do our best to follow up on them in the breakout session as and even following. So you know, back to the sort of panel identified questions that we shared it with panel members in advance a little bit. In thinking about these challenges and some of the questions we have, you know, just from sort of at least 2 of you, maybe 3 of you, in this whole scenario and ecosystem that we are facing here, what do you think are the biggest activation barriers? You know, I guess we've talking about a lot of them, but what is your, you know, thought about the biggest one? And on that, I mean, you could comment on certain solutions, but, you know, what might be potential solutions? You know, so what keeps you up at night? All right, Jonathan was first, and okay, go ahead, Markus. You want to go first? Go ahead. One of you. Let's see.
Yeah, so I'll try to keep it short. I think
okay.
it's the lack of a data culture, that data is actually cherished on a group level, that from the PI to the postdocs to the PhD students to the master students to the bachelor students, that you make sure they know whatever they produce is actually valuable. Okay, bearing in mind any errors or so, but that this is useful, that this is gold, if you want to stay in that lingo.
So the lack of culture.
We lack a data culture.
Do you think, though, that there is at least some cultural shift taking place?
To some extent, yes. So I have a lecture, for example, with bachelor students in material science, where it's called materials informatics, and portion of that is just about data and metadata from the ground up. Do you have a convention for file names? And I show actual examples from other collaborators that send me file names and undefined formats. So to show them the discrepancy between what I tell them should be the way and how people still do it that are maybe 5 years ahead in terms of their education. Yeah. So they just don't know.
Yeah, that's great. Jake just put something interesting in the chat, in the Zoom chat. How much of that culture shift should be PI top down, or, you know, so think about that. And I see that other panel members will comment on this. So
should it be the PI driven, or could it potentially be student driven? you know, for some PIs that are, you know, maybe more established but less well versed in the repository ecosystem.
I'm sure all our panel members have. I see Taylor is itching, and then Jonathan will talk. Go ahead.
I think you're
Taylor's
exactly
itching.
right,
We're gonna go Taylor, Jonathan, and then Kamal is and Dan, because I think all of them want to comment on this, and I think this is really important. So Taylor, then Jonathan. Sorry, we bumped you a little bit, but go ahead.
Okay, I'll keep it brief. There's this sad but true statement in academia that science advances one funeral at a time. And it's because it is so top down. And you get these academics who've done it the way they've always done it, and they're really closed-minded to change, or they don't understand it. Like when I think of the people, the experimentalists, for example, if I want to get them to start capturing data and they have no idea what a repository looks like, then they're not going to teach their students about best practices there, something they don't even understand themselves. So that's the problem. What's the solution? I'm really curious to see what a student up one would look like. Certainly the community is kind of going that way. If you look at like hackathons, the PIs aren't typically participating in those. The students are, and hopefully learning some skills and taking it back to their group. And then you essentially have like a super user in the group who isn't the PI. It's one of these students who's learned how to do this thing that shares it with the others. But until you change it from the top down, I think it's always going to be limited in its potential impact.
Thank you. I'm glad we have Dan on here so he can comment on this too. Yes, great. Jonathan, go ahead.
Yeah, and I mean, I agree with everything, and that it's, I mean, the problem of the culture, and I also wanted to bring the funeral quote Taylor brought. And so I think, I mean, the problem is really, I mean, how we kind of get people, or how we can get people the necessary recognition, kind of. I mean, we have things like data stewards, for example, at ETH, but I mean, this is usually not a viable career path. But they can, I mean, of course, if you have a data steward in a group, they can completely change the culture around data in the group. And so the question is, I mean, how we can, I mean, finance these, or how we can make them viable career path maybe in science. So that's one solution. And very short on the student-driven one, I'm actually in our group, or right now, kind of a few students actually got together and are kind of upgrading the GitLab with more automated workflows and full CI setter. And so let's say it can happen. I mean, as long as the PIs are open for it, the students can get together and improve something.
Thank you. This is really interesting. I will credit Jim Warren. He got in there and told us that that quote was most often attributed to Max Planck. Your quote, Taylor, and there's good stuff happening. Kamal, you want to comment? And then Dan, we got Dan here as someone on the ground. Kamal, you're we can't hear you, your sound.
Can you hear me? Yes.
Now we can. Yeah.
Okay. So I want to say we should not focus too much on data culture. What is science? We should focus on reproducibility culture. Those are two different things. Just because you have data does not guarantee reproducibility. So for example, when we were making the Jarvis leaderboard, we made a script, a shell script that will, for example, install software, run the execution, and 100% reproduce that job. That is where our ideal should be. And since we are starting this at MaRDA meeting and stuff like this, I think it's important to put in the students' head, this is the goal, reproducibility, not just upload your CSV file to Fixia or something, right? So just want to comment on that.
You know, maybe that's for the challenge group. What are some of the challenges, you know, in the end, you know, thinking about challenges and even in the breakout group, you know, maybe we're, you know, sort of figuring out the right question is the activation barrier. And maybe what you're, not maybe, I think you're suggesting, or you're saying clearly that the question should be about reproducibility. Yeah, interesting. Very interesting. I think it's worth further discussion. Let's see what Dan says.
Yeah, I think a large part of like making sure, or like what the activation barrier is just like letting people know that it's not that difficult to publish your data. Like, I think just showing people what the step-by-step are of like making good data that's like reasonable to publish, and then showing them how to publish it, I think will go a long way. Because after I've given these like tutorial sessions, I've had people come up to me and say, oh, I didn't realize publishing data was that easy. It's just a few steps that you have to do. So I think just letting people know that it's not that difficult and showing them how to do it, I think is the biggest thing. And I think that's largely going to come from the people that are actually doing that work. So I think having grad students lead that work, I think, is probably the best solution to that.
Yeah, and I think people, I mean, this always comes up, this is excellent, is needing proof of this is worth it. You know, that's really, you know, where's the proof that this is, you know, yes, it could be reproducible. I'd love to see somebody else use this existing data. I think that's, you know, real successful case studies showing proof of concept. Let's see. I'm going to move on to the awareness of repositories and see if folks can comment on this. Your awareness of repositories, I mean, because, you know, some of you are involved in just one repository. There's a huge repository landscape out there. You know, the lack of awareness in general. I mean, like we're talking about just, Dan, you gave a good segue about just the ease of publishing, but also the awareness and comfort with repositories. Could you comment on that? You know, do you have a favorite repository? And I think we got a little of that already, you know, but understanding how they operate, understanding how people could better find repositories. Could comment on, you know, it's hard. You know, if you're new and you know you have to publish your data, but where do I go? What might be some solutions there? What do you understand about the landscape? Dan, do you want to take it since you're still unmuted?
Yeah,
and then
I'll
we'll
take
see
it.
who else unmute.
So
Thank you.
I'm only really familiar with like two like databases, like Materials Data Facility and Materials Project, but I think both have like their advantages. And I do computational research, so I think I'm partial to Materials Project because they outline their calculations in detail, and they give you various ways to reproduce their data, and I think that's really helpful as a computationalist. But I think the ease of publication of your data with Materials Data Facility is also a big plus, even though it's a little more unstructured and it's harder to understand how calculations were done. I think it's still a great way to at least put your data out there, and just show people what you've done. So
yeah, thank you. Jonathan, you have your hand up.
Yeah, well, one short comment, I mean, in terms of finding repositories, we can come back again to research data policies, because ideally all journals recommend for each data type a certain repository or a certain list of repositories. Well, of course, the community has to agree on some, and there's some political, I mean, issues then associated with it. But in certain communities, we already have that, and we also have it more or less for crystal structure data in quite a few journals. So this would be, I mean, one way to solve the problem of repository findability and education.
Yes. Thank you. Kamal, it looks like you want to comment?
Yeah,
too,
just about finding repos, I put a couple of repositories which list all the major repositories of machine learning or data. Especially, it's very common in computer science literature. Like, it's very common to have best of XYZ learning, you know? So there's a best of atomistic learning, and somebody had made that effort. So I just put the link there.
Well, we all know there's list of lists, you know, like we got list repositories of metadata standards, and then the list of the repository, you know, same with the repositories, but there's not one place to go. I mean, even I have a doctoral student that's working on this right now, and she's actually looking at links that come from other sources in to see how many, you know, other sites link to it. So it's interesting. Does anybody else want to comment? There are so many good questions. I don't know if we're going to get to them all, but I'm going to move on to another topic just so we can get a taste of these areas that will help. And I see Ray Roberts actually even comment on this in the chat. I'm going to read Ray's comment, and then I'm going to read our targeted question, well, our question for the panel members, which is a major problem in our field, and is the raw data can be in gigabytes in size, microscopy videos. So there's there's no good way to share. How do we share more than just the metadata and plotted data and papers? So folks can actually reproduce the analysis or do the new analysis on the data. And I think there's some other points about size. So, you know, comments on how we grapple with the size of data, you know, type, format, and actual size. It's, you know, some of the material scientists I work with, they're like, you know, they're happy to dump a lot of their data, you know, because it's just too big to keep, you know, they're not. So thoughts on this, you know, I mean, again, looking for a sweet spot. Do we save everything? You know, how do we address that? How do we address the size issue?
I'll be brief. I was at a workshop just last week. I think it's NSF sponsored. There's the BISC Center at UCSB. It's a bioimage something. It's the UCSB Center for Bioimage Informatics. What they showed was a huge repository, which is way underutilized. They've got petabyte scale storage there. So it's on the cloud. So other people can access the stuff without you having to try and send data. And there's this initial upload. It hosts tools and other resources that are easily shareable. So that was something that I've been in this field for a long time and I'd never heard of that. And I'm sure there's others. I see David saying that also we could build our own resources if there's actual need for it. So I don't think that's the problem. I think it's uptake. It's getting people that idea of putting data in publicly available spaces and building tools on top of other people's data that has to sort of change, is my view on that.
Thank you, Taylor. I see both Markus and Jonathan have their hands up, and it looked like Kapil, maybe you had a comment too, or no?
Sure, I can comment.
Okay. We'll go Kapil, and then we'll do Markus and then Jonathan. Does that sound good?
It's Kamal, but yeah, I can go ahead.
Kamal, I'm
Yeah,
sorry. I'm so sorry.
it's okay.
Thank you.
I want to point out when I started, okay, can you guys hear me okay? Yes. So when I started Jarvis, there is about 300 or 400 terabyte data. And I uploaded most of that on Fixture and NIST internet. The reason was because there was a REST API. I never want to upload one file by one file. That's most of the data repository do that. That's not going to happen. So unless you have a way to put your data using API, using a cron job or something like this, this problem is going to be there. So that's something I want to point out from my perspective.
Camille, thank you. Thank you so much. Markus?
Yeah, I'm with Taylor. I don't think that the size, the sheer size of the data is the problem. It's rather that you have to connect it somehow back. The APIs were mentioned, Optimate was mentioned. We don't have Optimate for experimental data. You could maybe think of, I want all TM images or all microscopy images from a specific material. So you would sift through the metadata, whatever that is, whichever format that is. And I think the problem comes afterwards when this data exists somewhere that you can actually pull together different data sets.
Yeah.
And the API was mentioned. That was also one of my points. Make it easy for people to upload and not care.
Yeah. And does this go back to the culture or the reproducibility as being the motivator, or both? In terms of our target, I'm going to toss it to Jonathan. Go ahead.
Yeah, so definitely emphasizing, I mean, the API is important. For example, in the beginning, when we didn't upload data to Nomad because uploading a few million calculations that just, I mean, was quite painful. This, I mean, has changed now, for example. And then there was the question of, do we save everything? And I would strongly encourage, yes, can just say, for example, for materials project, we have these universal force fields. I mean, these universal force fields exist right now. And to build them was essential that, for example, for the materials project, all geometry relaxation data was saved at the time, and nobody knew why this data would be important. And for us, we actually didn't save the same data for kind of during the first half of our database building. And because of that, we are now missing maybe 30 million energy structure pairs. And so, yeah, I can definitely encourage just save everything. But the size is a problem. I have no solution.
Thank you. Markus, do you have another comment?
Yeah,
or-
just
yeah, thank you.
just very short
Fine.
support of the point that save everything. Maybe you know of the combination of the astronomer Tycho Brahe and Johannes Kepler. So the one was the one who recorded the motions of the planets in the sky, and the other one was who formulated the laws of the motions actually, and showed that we're not that the planets revolve around us and around the sun. So you won't ever know what someone could do with your data if they have different capabilities or different techniques to do it. So there are precedents in history, not only for atomistic data, where data is useful at some point years later.
Yeah, I mean, there's a phrase in my field, information science, called undiscovered public knowledge, things to be discovered later. So it's a very, very interesting point. Yeah, I think we're really getting some nice answers, thoughts, and really good discussion here. So where is that question about having, okay, so here's a thought from Andrew. How about having a Slack or Discord front end for the community to collaborate attached to a knowledge graph database back end for both publication and dissemination data? It's a discussion point. Thoughts on that? Perhaps comments, or does that require more thinking? No comments. Yet another knowledge graph? I don't know. Somebody's putting. Alrighty. Something to ponder and think about a way to bring the community together. Alrighty. Let's see. Jake.
Maybe
ahead.
I can.
Go ahead.
Yeah. So again, in this collaborative research center that we have a dedicated project by a computer scientist who's creating a knowledge graph on top of the research data management. For if the hope is that we can efficient and very clever queries to get the data together. But again, as I said earlier, I think this is very hard to organize on a community level rather than on a personal level in smaller research groups. That maybe answers the question.
Yeah, thanks for your comment. And Allison on the Zoom chat just sort of jumped in a little bit too and said, not necessarily a Slack, but I've always wished it was easier to collaborate with different people. So I think we're just getting into a topic about collaborating, in this area. And I see Jonathan's hand went up really quickly.
Yeah,
Jonathan,
maybe
a comment.
just also as we're organizing the session today. I mean, this will be the point of the discussions later on the breakout rooms, and we want to arrive at actionable points, and we want to, get people to connect exactly to start such projects. And if there's somebody interested to build such a project, and use the MaRDA community to do that, then I think that's great, and that's what we can, hopefully achieve later on today.
Great. All right. I think I'm making it through here. Does that mean it is useful? Yes. Somebody said, okay, sorry. A new question by Rushik about maintaining interoperability between computational and experimental data. I think this is quite interesting. If we are envisioning a common storage point, what are the strategies we need to follow and maintain interoperability? So they're talking about interoperability between computational and experimental data. Looks like David's getting in there with some answers, but thoughts from panel members on any thoughts? Markus? Is your hand still up from before? Or yeah,
no, again, this is also exactly one of the problems we have in this research center, to make the connections between predictions from theory and simulation and various experimental techniques. And I would sort of diffuse the question a little bit, because I don't think we could maintain this connection, because this is largely not there yet. So we're even alpha, or I don't know, Stone Age, or what did you say, Bronze Age in this regard.
Well,
And
I like to think we're in the Bronze Age
yeah,
instead of
whatever, not in the
That's my
information
hope.
age, definitely. But the point, so the way we're discussing this, or we're thinking about this, is kind of a coordinate system that you need to find. So you could maybe say composition is a common point where you can make a connection, or something like that, because there you could combine atomistic simulations and surface measurements. But does that really make a connection? One has maybe been heat treated, one has been sputter deposited. So all these sorts of dimensions that you can attach to what is considered a material, because it's not only the composition, it's also its history. And how can you even compare this? So finding this coordinate system is one of the tasks we as a community still have. So it's really not about maintaining a connection, other than maybe examples where people did this in papers and they designed the experiment so that it matches the simulation or vice versa. But on a large scale, I think this doesn't exist. So there is nothing to maintain, but something to develop, actually.
Thank you. Jonathan, go ahead, jump on in.
Yeah, maybe one should, I mean, as Taylor already brought up before and others, the LLMs, I mean, are or can be an opportunity in this direction. That, of course, some latent space can be a coordinate system where, of course, we do not necessarily know the meaning, but it can be a very useful coordinate system to, if we have some, I mean, multimodal models or LLMs that can operate on both, I mean, text, of course, from theory and experiments to combine the two to some extent.
Excellent. Kamal, do you want to comment too?
Yeah, not too much about the newly synthesized material, but existing commercial material, there's something CAS number, right? That we might be familiar with. So I think this CAS numbers has been barely mapped out to ICSD IDs or Jarvis ID or Materials Project ID and so on. I think something along those lines might also be useful. That's just one comment.
Yeah, thank you. Thank you very much. We have about 10 minutes left. I feel like this is a marathon. There's lots of comments, and some things in the Google Doc and the Slack are more comments or questions and so forth. What I'd like to ask maybe one more question, but also a question of all of you on, is there a question you wished I had asked or we had asked in planning this, or a comment you want to make about this space? So put that in the back of your head for a few minutes while I ask you this last question. Then I just want to open it up and around the room in terms of perhaps, getting ready to closure. We might end a minute early, so people can have a quick bio break before the thing. But just the last question I'm going to draw from here, and as I will just say, if your question wasn't asked or your topic wasn't discussed, again, we have the afternoon session. But the bounce between, the general purpose repositories, something like BISC or a university repository, even Figshare versus the materials repositories. I mean, in some cases, I think you couldn't even think of putting materials data in some of these more general repositories. In other cases, it could be fine. And what are your thoughts on this bounce? Do we just, Fran Berman, when she was head of the Research Data Alliance, used to say, let it all hang out, let 1,000 flowers bloom. Is that the way to go about this? Or is there need to be, maybe some more, I don't want to say gatekeepers. There's, in the beginning, we were talking about journals having policies, but, follow-up, there's, at this point, there's no, data sharing police that go after you, I mean, some journals, if, they want the DOI for your data or the persistent ID. But back to the question, this bounce between the general and the specific and moving forward in developing, I would like to say, a more cohesive, robust data sharing ecosystem. And I like Kamal's thing about a data reproducibility ecosystem instead. Thoughts on that? Anybody have any? Nope.
Yeah, I'll bite.
Thank you, Marcus. Yay, Jonathan. All right. It's like a
Jonathan, you
game
go
show.
first. I had more talking time.
Go
Okay.
ahead.
Well, and then maybe one short comment to start. If we can have specific repositories, and then that's great. Kamal mentioned the Optimate API, and for example, Materials Cloud has something now where you can upload a data set there that will be more or less automatically made available through Optimate then. And then this data, I think, is infinitely more useful to the community if everybody can just include it in their query through an existing API standard. So I'm very much in favor of that if it's possible.
Yep. Thank you. Marcus?
Yeah, that was part of my answer. What we should have is an access point that is common, but the data can live wherever. So if someone is more comfortable hosting it in their own server, but they provide an API that is standard like Optimate, then this is beautiful, because then you can actually make use of the data. And to add to this a little bit, I have the feeling and still have the feeling that with some of the technologies that we're deploying or trying to deploy to manage research data, like coming up with an ontology, we're actually forcing a concept from computer science onto something that was never meant to be. So as a material scientist, you think now you have to define the world. So what is a material even in the first place? And you can go on for days discussing how you define a material. But what ontologies were intended to do were actually harmonizing data across databases. And that's maybe something one could step back again and say, okay, maybe that's the real use we can put into harmonize across different databases and make them usable through maybe one API, but that still has to be, let's put it like this, defined what this could be for other than atomistic data, where it's comparatively easy. I mean, it's not easy, but comparatively easy to the heterogeneity of experimental data.
Yep. Back to trying to find that sweet spot. I like it. All right, we're at the 5 minutes left. Wonderful discussion, lots of juicy stuff to continue discussing. And, you know, the phrase, can we move the needle forward? I think there's a lot of interest and excitement, and MaRDA is the place to carry this, you know, or a place, given the people involved. Just in and around the room, was there, you know, if nobody has any comments, it's fine, but, you know, oh, I wish you had asked us this or this, I wanted to make a comment about this. Just give our panel members, as all of you each bring expertise, just open it up for final comments, thoughts. Anybody have a comment? Or please add this topic to the discussion in the afternoon. Okay, I see Taylor and then Jonathan. Go ahead, Taylor.
Something that came up over and over is culture. And I just will point people out. It's sort of like when people say like they don't, like you can't change the government, like what's my vote going to do? But like we are the culture. The people on this call and our students and our peers are the culture. And so maybe make a decision, if nothing else from this meeting, like decide one way that you will implement better data practices into your workflow today, and then make it happen.
Good, thanks. It's really positive too. Thank you, Taylor. Jonathan, I saw a flash of a hand.
Yes, one short comment or one, I mean, of the big challenge we heard from Markus already, that it's a challenge to implement these at the, even at the university level or at the lab level. And of course, now here it's mostly the US, but it's, the challenge is definitely that, or it would be great if these efforts can be more connected. Also between US, Europe, and in Europe, it's already a challenge to, of course, also the different countries, and in Germany, the different states, etc. So, the more of the community we can get together for something like with Optimate, where it's, also across the whole world, then, the more effective the outcome in the end, maybe.
Yeah, this discussion taking place here, right, is something, I don't know if it would have taken place, 10 years ago in this way with, you know, I mean, a question I have is, do we have all the stakeholders? You know, I think engaged in the discussion. And one thing I think is, given the discussion about training, we probably need more students. How can we reach them? But okay, I didn't mean to segue. Other comments from panel members, thoughts? Yeah, go ahead, Markus.
I'm sometimes faced with sort of a bad attitude towards all this. What's this all going to bring? And so this kind of vibe that you get from people who are maybe reluctant to change parts of their running system in their group and so on and so forth. But I'm then reminded of one of my earlier supervisors for it's called a diploma thesis, or the equivalent of a master thesis, who told me that if it would be easy, then someone else would have done it already. So this is a great challenging problem to work on, even if it's very tedious. And I think the developments in the last years for non-materials data and data-driven things like the LLMs and other things like maybe autonomous driving or safety features, it's just a technology. So it's what we make of it. And if we're not part of this, then we're not benefiting from it at some point. And so this is the groundwork, the data to enable these kind of new directions for analysis. And who knows what's going to come.
Great.
So Jane, I saw that our major chairperson of the meeting had his hand up. So I don't know if David wanted to pipe in before you finish.
Okay, I just
Oh,
let David
sorry.
pipe in 1 second. David, hold on. My question would be to all of you, and there's no time to answer this, but can we have AI take care of this whole problem for us in the future? Okay, don't answer. I see that you can answer with a yes or no. David, you want the last word?
Oh, I didn't. I'm sorry. Taylor jumped
Yes.
in. It was just about culture. You know, I think that we've been talking about culture in the MGI for 10 years, and I don't think culture has ever changed because somebody told somebody to change their culture, right? It happens because of how people behave and getting benefits out of these things. And so it comes really, that's why MaRDA is important. It comes from the grassroots. When people do things a different way and they get some great result, other science teams want to do it. So we need help from above, but it really comes from our own behavior. Mostly if people tell us to do things, human nature is to do the opposite anyway, right?
So I'm going to end on having more interdisciplinary teams. So someone who comes from a background in information and data science, when I started working with material scientists on their data sharing, given the background I had in bio, you know, I'd ask them where they're sharing the data. And of course, you know, the answer is, oh, I have it. It's on GitHub. And now a lot of our material scientists are like, oh, right, there's repositories, you know, they're waking up. So moving forward, we have a lot of stuff to discuss and address, but I think it is time for a poster session. And I just want to give our panelists a round of applause and thank you for all your great thoughts. And hopefully we'll get to see some of the people who are, you know, our panelists who can attend our breakout group on this topic or go to another one if you want, and some of the people who participated here in the audience. So thank you very much, everyone.
And I think we also have to thank Jane. I think she did an outstanding job moderating, and thank everybody in the audience, and the participation was outstanding. And let me remind everybody, we have a working group already established for this. And so Jane will talk more about that in the session this afternoon. So I see this is very exciting for people. You have an opportunity to continue this conversation beyond this meeting. I think one of our goals is for MaRDA to provide some guidance to the community on this, and so we need to do it together. So with that, I'm going to turn it over to Jonathan to introduce the next section of our meeting today. So Jonathan.
Thank you, Linda.
And thank you.
Yeah, thank you again to the whole panel and to Jane for leading the discussion. And yeah, we will have the poster session now. In the meeting, so the meeting links for GatherTown should be also in the agenda on the website. I'm not sure if they are also in the chat. Right now, I don't know. Maybe they can also be posted in the chat, else they will be on the agenda. And yeah, of course, there will also be poster prizes, $500 in different categories. And yeah, encourage everybody to go and see the posters. I can personally confirm that the poster sessions can be very useful for making connections. So last year I actually presented a poster also at one of the poster sessions. And I actually met Jim Warren there for the first time. And this is kind of the long story of how I ended up here. So yeah, definitely go to the poster session. They're great to learn something and make some connections. And then if there are any questions about GatherTown or anything with the poster sessions, Selena will be there to help us out. Yeah, Linda, do you have anything to add?
No, I think I just want to encourage people to visit the poster session. The people that are presenting the posters, students, postdocs, other faculty, I think it's really important to support them in their efforts because we want to, you know, make this community very strong. So thank you, and hopefully you'll be able to participate also in the discussions this afternoon. We're really excited. Thank you.
Great. And David put the link to GatherTown if people need it. They're in the Zoom.
Okay.
Thanks, everyone.
Thank you.